Okay, previously we talked about the distance around the circle. So the distance, remember the distance around the circle is circumference, and circumference is 2 pi r. 2 times pi times the radius, or pi d, pi times the diameter. And then what we did is we talked about, what if we don't want to go all the way around the circle? What if we want to go part of the way around the circle? Well, if we want to go part of the way around the circle, then it would be theta over 360 is equal to how far the arc is, right, s, over how long, right, not how many degrees, this is how many degrees, but how long, divided by the entire circumference. This is all part over whole. The reason I'm pointing this out is because I want you to see what we're going to do today is very similar, okay? Don't confuse the area of the circle with circumference. The area of the circle is the amount of space inside the circle. Okay, so where circumference is like the hula hoop or the bicycle tire, okay, this is the cheese covering the pizza, the sauce on the crust, okay? That's what area is. It's inside. And the formula for that is pi times radius squared. Now, it's really easy to get confused because there's a pi and there's a 2 and there's an r. But this is pi r squared, r times r. This is 2 times r. They're different. Okay, 3 squared is different than 2 times 3. So they're very different. Okay, so number one, let's just start basic. Find the circumference and area of a circle that has a diameter of 24. Okay, if it has a diameter of 24, it means it has a radius of 12. So circumference is 2 times pi times radius, or 2 times pi times 12, which would be 24 pi, right? 2 times 12 is 24. The pi is just going to go along for the ride until I decide I want to use that key on my calculator. We're going to use the pi key. We're not going to use 3.14. And then 24 pi approximately is 75.4, and that's centimeters. That's the distance around. So the distance around a circle that has a radius of 12 centimeters is 75.4 centimeters. Area is pi r squared. Pi times r squared. R squared, 12 squared is 144. Okay, so exact in terms of pi is 144 pi. Approximate would be 144 times pi on your calculator, which would be 452.4 centimeters squared. Remember, we don't round until we get to the end of the problem. Okay, number 2 says to find the area of the circle if its circumference is 32 pi. Well, let's talk about this. Well, circumference is 2 times pi times r, and area is pi r squared. Now, these are two completely different things, right? Circumference is the distance around. Area is the space inside. But they do have one thing in common, and that is the radius. So if I can use the circumference, because I do know the circumference is 32 pi, if I can use the circumference to find the radius, then I can find the area. So circumference is 2 pi r. My circumference, I told you, was 32 pi. 32 pi is equal to 2 pi radius, 2 times pi times the radius. Well, let's divide by 2 pi and divide by 2 pi. I don't need that many parentheses. I don't need that one there. The pi's cancel out. The 2 pi's over here cancel out to 1. And then 32 divided by 2 is 16. So the radius is 16. So the radius of that same circle has 16. Well, then the question is, what's the area of that same circle? Well, area is pi r squared. 16 squared is 256. 256 pi is my exact answer in terms of pi. Multiply 256 times the pi key, and you get approximately 804.2 centimeters squared. That's area. Circumference, right, that's 16 centimeters, right? Circumference is the distance around. All right, so let's look at some partial circles, okay? This will set us up for where we're going with area of a sector. A semicircle, remember, a semicircle is half of a circle. Okay, it's half of a circle. So I want the area. That's a semicircle. I want the area of it. Well, the area of the entire circle would be pi r squared. The radius is 6, so pi r squared. That would be full circle, 36 pi, but this is a half circle, so I'm going to divide it by 2, and I get 18 pi. So my semicircle area in terms of pi is 18 pi, which is approximately 18 times pi is 56.5, and that's centimeters squared. It would be a good idea, just kind of as a side note, for you to not just trust me on these when you type them in the calculator, at least test me, okay? Type a few of them in on the calculator, make sure you get the same answer that I do so that you can ensure that you're using the pi key correctly. The length of the arc, I want to actually know how long this arc is, right? That's the length of the arc. It's 180 degrees, that's the measure of the arc, but I want to know the length of the arc, okay? Well, it's a semicircle. If I find, so one of my options is to just find the full distance around and then divide it by 2. Well, the full distance around would be 2 times pi times the radius. That's 12 pi. It's half, so we're going to divide it by 2, which means the length of the arc is 6 pi. Okay, that is 6 pi. Let's see. I didn't have that answer. 6 pi is 18.8. Now, the perimeter. So what I'm asking for is the perimeter, which is the distance around this particular shape. If this is a garden, right? How many centimeters of fencing would I have? That's a really small garden, but what is the distance around this shape if I was going to outline it in ribbon or paint or something? Well, perimeter then would be this is 6 because the radius is 6 all the way around the circle. This was 18.8. So my distance around exactly would be 6 plus 6, which is 12. So 12 plus 6 pi. I cannot combine those. Those are not like terms. It's kind of like 12 plus 6x. You can't combine those. Approximately then would be 30.8. Now, it can be 6 pi plus 12. The order of that doesn't matter. Okay? Okay, so that's a semicircle. How about a quarter circle? Well, a quarter circle is exactly what it sounds like. It's a quarter of a circle. So if I find the whole circle, pi r squared, the radius is, so that's 64 pi. That's the full circle, but this is a quarter of the circle. So that's divided by 4. You get 16 pi. In terms of pi, my answer would be 16 pi. That's 1/4 of that circle. If you multiply that out, that's 50.3. That's centimeters squared, because area is always squared. The length of the arc, I want to know how long this arc is, right? That's what we're looking at. Again, it's a quarter of the circle. So I can take that and I can say a quarter of that circle. So all the distance all the way around the circle. This is one way to do it, right? You can still do 90 over 360 equals, just like we did before, but this is easy enough. So all the way around the circle, that if it existed, would also be 16 pi. That's coincidence. That doesn't always happen. Divided into 4 pieces, and that's 4 pi. So 1/4 of the distance around is 4 pi in terms of pi, or 12.6 approximately, rounded to the nearest tenth. So the perimeter of this shape would be 12.6 plus 8 plus 8. So that would be 16 plus 4 pi left in terms of pi as an exact answer, or 28.6 centimeters. Perimeter is the distance around the shape. Okay? Number 4. Find the perimeter and the area of the shaded region. Okay, M is the center of the circle. So this is a semicircle with a smaller semicircle cut out of it. This is what we would call a composite shape. So what we want to do is we want to find the area of the big semicircle, and we want to subtract the area of the small semicircle. We have a hole. If it was turned like this, right, if I had it this way, then we would add them. It's not a very good semicircle, but pretend. Okay, so we're going to find the area of the big semicircle and subtract the area of the small semicircle. And then we also want perimeter. So we need the arc length. We need half the circumference, half of this circumference, plus this straight piece, because we're going to put a fence all the way around it. Okay, so let's do perimeter first. All the way around is easy to go, right? All the way around would be 2 times pi times the radius. The radius of the big semicircle is 12. And that's 24 pi. That's the whole thing. We're going to divide that by 2 because I only have half. So that's 24 pi. Okay, so this distance all the way around, the distance is 12 pi. That's 12 pi. Then we need this distance, right? This has a radius of 6. So we need the perimeter of my small one, right? We need this arc length. So that's 2 times pi times 6. That's 12 pi. That's full circle divided by 2. That's half circle, 6 pi. Okay, so this is 6 pi from here to here. So my perimeter would be 12 plus 6 pi plus 12 pi. Semicircle, semicircle. Make sure you're paying attention to semicircles. Well, then that would be 12 plus 18 pi in terms of pi, which is approximately 68.5 centimeters. Area, you can do the same thing with your area. Area, find the area of the whole circle, pi r squared. So it's pi times 12 squared, and we're going to divide that by 2. So that will be 72 pi, 144 divided by 2. That's 72 pi. That's this piece, 72 pi. Then let's find the area of this one. That would be pi r squared and divide by 2. So 36 divided by 2 is 18 pi. We're going to subtract them. So my entire area would be 72, that's my big area, pi, minus 18 pi. And exact, they don't subtract, the pi's don't subtract, right? Those are like terms, we can combine those. 72 pi minus 18 pi is 54 pi, which, multiply that out, 54 times the pi key is 169.6, and that would be centimeters squared. Okay, so big thing, pay attention when you've got half circles. Don't forget to divide by 2 because it's a half a circle. And when you have composites, if you have a hole, you're going to subtract it away. If you are adding it, if you have a mound or a growth on it, then you're going to add it to it. Okay. Now, let's go then from there and talk about the area of a sector. So this is called a sector. It is a portion of a circle. So it is the fractional piece. So this is where it's similar to what we did the other day with the distance around with arc length. It is the fractional part of a circle, okay? And it's the fractional area part of the circle. So it's that. So the circle doesn't actually exist, like this is all we're looking at. Now, what we're doing is the same thing, part of our whole, right? So it's however many degrees over 360 is equal to the area of the sector over, right, part of a whole. However many degrees out of 360 degrees. However much area is that over the area of the whole circle, which is pi r squared. You can also get the same thing. The area of the sector it's a part of a whole, right? Part of whole. In math, of means multiply. So what part? The fractional part of the whole thing. It's just sometimes this is difficult to use because of the questions I might ask you. Okay, I might ask you to find theta. I might ask you to find the radius. And so you're going to have to know how to use the equation. And I think this one is easier to use. Okay, let's look at number 5 then. It says given circle Q, where QS is 5. and the angle RQS is 63. Find the exact and approximate area and arc length of the shaded sector. So what I want is I want that area. I want the area of that piece of the circle. Now, before, we could just divide by 2 because it was half, divide by 4 because it was a fourth. If it was 60 degrees, I could divide by 6 because it's 1/6 of the circle. But 63 is not a whole part of the circle, right? It's not like a nice fractional piece. 63 over 360 degrees isn't nice and pretty. So when we set this up then, the area of the sector, we're going to do part over whole. So what part over whole of the degrees? It's 63 degrees out of 360 degrees. That is equal to, so that's the fraction of the circle. I want to know the area of the piece. So I'm going to put area of the sector. That's what that means. Over the whole area. Whole area is pi times r squared. Okay? So that's 25 pi, right? So if we want to simplify it as we go, 63 over 360 is equal to the area of the sector over 25 pi. So this is my ratio, right? This is my scale factor. It's this fraction of it. But the easiest way to do it is you cross multiply, right? So we would do 63 times 25 pi is equal to 360 times the area of the sector. Divide by the area of the sector, divide by that 360. Now look, y'all, see this theta over 360 times the area? See, this creates it, right, when we divide. So they both came from the same place, the area of the sector. So you type it in. Now, it's not going to come out pretty. Don't multiply pi yet because I want it in terms of pi. It's 63 times 25 divided by 360. You get this decimal. Okay, if it asks you to leave it an exact, then just math enter it back into a fraction. Let the calculator handle that for you. So we get 35 over 8. And still pi. We didn't use the pi. Which is approximately, if you take 35 over 8 and you multiply that by pi, you get 13.74. Now, I want to show you, okay? So, whole area is 25 pi. There's the whole area. And if I multiply that by the fraction, times 63 divided by 360. See? Same thing, okay? So, again, you can think about this part times whole however you want, but I just want you to keep in mind using this proportion so that depending on what piece I give you, you can do that. Arc length, that goes back to what we were doing the other day. Arc length is the portion of the distance. I want the arc length of RS. I want to know how far it is. Well, the measure is 63 out of 360 degrees. So how far is it? How far is the arc length? And we use S, I don't know why, times 2 pi times the radius, which that's 10 pi. If you need to, you just 10 pi, right? Cross multiply. 63 times 10, hold on to the pi, divided by 360. Let's let the calculator handle it. That's 7/4 pi. Well, 7/4 times pi is 5.5. So the length, now let's look, all the way around is 10 pi. That's all the way around. So let's just divide that by 6. Divide by 6. Well, that's pretty close, right? 60 degrees is pretty close to 63 degrees. 60 degrees is 1/6 of the circle. So 5.2 is pretty close to 5.5. It's a little bit more. So it's a little bit more than 60. Just to show you kind of how it works. Okay. So I want the area of this sector. This time I can only see the sector, but it does belong, right? It is a portion of this whole circle. The area of the sector then would be 135 over 360 is equal, part over whole, is equal to the area of the part over the area of the whole. Okay. 36 times 135 divided by 360. You get 13.5. That's 27 halves pi. We didn't use the pi key until now. Times pi. You get 42.4. Okay. If it had been 120, that's 1/3 of the circle. So you could just divide it by 3. Arc length is how far is it from here to here. That's a portion of circumference. Again, 135 over 360. Notice the similarities between them. The only difference is what you put on bottom. What is the whole part you're looking at? Are you looking at the whole area, or are you looking at the whole circumference? The whole space inside, or the whole distance around? Well, this is 12 pi, right? 12 times 135 divided by 360 is 4.5. That is 9 halves pi. You can also write 9 pi halves, by the way. They're the same. Times pi. And you get 14.1. Now I want the perimeter of sector AOB. So I want the perimeter of this. Okay, so remember this is what we had. This was 9 halves pi. You could also, it is not wrong to do 4.5 pi. That's not wrong. Usually I just don't like to use repeating decimals, but if they end, that's okay. You can write it that way. So the perimeter of sector AOB would be 4.5 pi plus 6 plus 6. That would be 12 plus 4.5 pi, which is approximately 26.1 centimeters. You just go ahead and add them. 12 plus. Now, it's not 12 plus 4.5. It is 12 plus 4.5 pi. It's not 12 plus 4.5 and then multiply by pi. Okay, so be careful about how you type it in. All right, the last question says the area of a sector is 22. The central angle associated with the sector is 45 degrees. Find the radius. All right, so let's look at what we've got. I think it's useful to have a picture. So I have a circle and I have a sector, and the area of that sector is 22. I know the part of the circle. The angle is 45. Find the radius. All right, well, if we go back to our original proportion, right, this is 45 degrees out of 360 degrees. This time I know the area of the small piece, I know the part, over the whole, pi r squared, and I'm asking you to find the radius. Okay, so when you cross multiply, you get 45 pi r squared is equal to 360 times 22 is 7,920. Now here's where you got to be really careful, right? I'm dividing by 45 pi. Notice I put it in parentheses because I'm dividing by 45 and I'm dividing by pi. If you don't put it in parentheses, if you do this, if you do 45 pi like this, the calculator will read from left to right. And it will divide by 45 and then it will multiply by pi. That will be wrong. I want to divide by 45 pi. And I get that the radius squared is 56.0225. Let that sit there. I didn't ask for r squared, I asked for radius. So we take the square root of our previous answer and we get 7.48. It says round to the nearest hundredth, 2 decimal places, 7.48. Now, let me show you another way, because this is not the only way, and you may not have thought of it this way either. You may not have worked it this way. So if the sector is 45 degrees, then 45 degrees, well, out of a circle, 360 divided by 45, there are 8 sectors that are 22. Of the whole circle, this is part of the circle that represents 45 degrees, right? And there are 8 45-degree sectors. There are 8 slices of pizza that are 45 degrees. Okay, like that. So that means 22, 22, 22, 22. The area of each of these pieces is 22. So if you take 22 times 8, that means the area of the entire pizza is 176. Well, an entire pizza is pi r squared. 176 divided by pi, because we need to isolate r squared, divided by pi. Does that look familiar? So 56.0225 is equal to r squared. Again, square root of our previous answer, and we get that r is 7.48. Both ways work. This way is easier. Obviously, look at all the work difference. If you can do the thinking part ahead, that means you have to have a good grasp on what the area of a sector is. And the area of a sector, in short, is a fractional part of the whole circle. And of means multiply. So what fraction is it? If it's a third, a sixth, a fourth, those are easy, right? This is an eighth. But if they're weird numbers like 135, 63, then we have to understand how to use the equation to solve the problem.